Okay, so today we are going to discuss equilibrium of concurrent forces. Are you able to listen me?
Yes, sir.
Okay. So there are two concepts. Okay. By one concept, one concept is used known as Lami's theorem. Okay.
Okay.
So, but Lami's theorem is only applied if the three forces are concurrent. So, it is applicable only for three forces. Lami's theorem. So, when you have three concurrent forces, then you can apply Lami's theorem, LAMI. It is LAMI's theorem. So, let us say this is your point P and three forces are applied on this point P. Like we have one force this side, another force this side, and this force is this side. Let us say this is your F1, F2, and this is F3. These are three concurrent forces, isn't it? Because they are applied on P. They are originating from P or they are applied at a single point, then these type of forces are said to be concurrent forces.
Okay.
Okay. So,
They originate from a single point.
yeah. So, that says your concurrent forces. Okay. Just a moment. Okay. So, what Lamy theorem says, let us say this angle between F2 and F3, let us say it is alpha, and F1 and F3, this angle is beta, and angle between F1 and F2, the angle is gamma. Okay. So, what Lamy theorem says that F1 upon the angle in front of F1, the angle in front of F1 is alpha. So, we will take it F1 upon sine alpha. Okay. If you are taking F2, F2 upon what will be in the denominator?
Beta.
Sine,
Sine beta.
sine beta it should be. So,
Yeah.
it should be sine beta, and if it is F3, F3 upon,
So isn't this just called sine rule?
it is not sine rule. Sine rule is used in a triangle. It is not a triangle, isn't
But it's
it?
very similar to it.
Yeah, it is very similar to it, but it is not a triangle. Got my point? So, we can use Lamy's theorem if three concurrent forces are given. Okay.
Okay.
There are another ways also. We'll discuss it. Please note it down. And these three forces are in equilibrium. Okay.
So whenever three forces are concurrent, they are in equilibrium.
No, 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 no.
Exactly. What if
The,
they have different magnitudes? Not that.
these are three concurrent forces and they are in equilibrium.
Okay, you're stating that.
Yeah. So, F1, F2 and F3 are concurrent forces and they are in equilibrium. Then Lamy's theorem stands. Okay. They must be concurrent and in equilibrium. That means, like if it is a pole and this pole is supported by three strings, one is from this side, one is from this side, one is from this side, and this pole is not going anywhere. So that means we can say that three forces, whatever is applied by the strings, so these they are in equilibrium and they are concurrent. Okay. Getting my point?
Yes. Done. Okay.
Done. Okay. So now we'll do some questions, then you will understand it, how Lami's theorem works and how concurrent forces, equilibrium of concurrent forces works. So we'll take one example. This is example taken from NCERT book. So what we do, if we're talking about concurrent forces, is it visible?
Yes.
Okay. So here you can see it is 6 kg weight. Okay. Mass of 6 kg is suspended by a rope of length 2 meters from a ceiling. This is your ceiling. This 2 kg mass is suspended by a rope. A force of 50 Newton in the horizontal direction is applied at the midpoint of the rope. Do you understand? This is P. P is the midpoint of rope and 50 Newton force is applied horizontally. Okay?
Yes.
As shown in figure. What is the angle the rope makes with the vertical in equilibrium? So let us say this mass is in equilibrium. So what angle the rope is making with the vertical? This theta is to be calculated. Okay. Now you just have to think how many forces are applied, where forces are applied, in which direction they are applied. Okay. So as it is, weight will be downward,
Yeah.
T2 will be upward because of this point, isn't it?
Yeah, it's
Because
away from the point of attachment.
yeah, because the force is applied here, and here from here to here that will be a different tension.
Yes.
Okay. So let us say it is T1.
But sir, how can tension 3 exist? It's not attached in. It's not attached to anything.
But the force is applied, so it is a pull. So pull,
Okay. So something is there which is pulling it.
yeah. So that pull will give its tension. So that tension will be equal to the pull, isn't
Okay.
it? So that is
Yeah.
50 Newton. It is given. Got my point?
Yeah.
Okay. So you just have to think how many forces are there, T1, T2 and the weight of the body. These are three forces and this is T3, that is 50 Newton, that is given to you. Now you just have to think, let us say this is T1. So will it be T1 sin theta and that will be T1 cos theta?
Yes.
So this will be T1 cos theta and this will be T1 sin
Sin
theta.
theta.
Is there any doubt in that? In
No.
components of a vector?
No.
Okay. So that T1, T3 is given like 50 Newton, it is already given.
Yeah.
What force is in opposite direction of T3? If it is in equilibrium, so sum of all,
T1 sin theta.
if this entire body is in equilibrium, so sum of all forces will be
Would be
0,
zero. Yeah.
isn't it? So that 50 Newton will be balanced by T1 sin theta, isn't it?
Yeah.
Because that is only horizontal force applied on P. So
Yes.
that will balance each other. So from this point of view, we have taken 50 Newton will be T1 sin theta, isn't it?
Yeah.
So that becomes your equation number 1. Now what is balancing T1 cos theta? T1 cos theta is upward and T2 and your weight. These two things are also there.
What's the answer for this, sir?
Answer for
This.
T1 cos theta will balance.
Will it be 50?
What? What will be
No,
50?
not 50. I mean, 1 second. Because we can just take, can we just use trigonometry for this? That's what I'm asking. Hello?
Yeah,
Can we just use trigonometry for this? We can take the value of T1 sine theta as 50. So we will have the hypotenuse and opposite. Can we solve it that way?
beta T1 sin theta is a vector. It's not a
Yeah.
magnitude. Okay.
Yeah.
So we can't apply trigonometry here. Got my point? Now T1 cos theta is balancing what? It is balancing T2, isn't it? And T2 is balancing what? T2 is balancing the weight 6 into 10. So that will be 60 Newton. T2 will be 60 Newton, isn't it?
Yeah.
And this T2 is being balanced by T1 cos theta, because T1 cos theta is upward, T2 sin theta, T2 is downward. So that means your T1 cos theta would be how much? 60. That is your equation number 2. Now if you divide this, what will happen? T1 T1 cancelled. So 1 by 2. So we'll get it sin theta by T1 sin theta, T1 cos theta equal to 50 by 60. T1 T1 cancelled. So your tan theta is 5 by 6. So theta is tan inverse 5 by 6. Got my point?
Okay.
So that must be the answer.
1 second.
And if you find it by calculator, that will be 39.8 degree.
39.80.
Yes. So in these type of questions, you need to think what force is balanced by what force. Okay. Got it, beta?
Yes, sir. Let me note it down.
Okay. Kyra, you can join us from 2 to 3, Monday to Friday.
Done, sir.
Done?
Yeah.
Okay. So next question for you. Let's try to do this question. This is like same question. You need to determine tension T1 and T2 in the string shown in figure 5.3a. Okay, some sort of solution is also given. Don't think about it.
Okay.
Just take the figure.
Yes, sir.
You need to focus only on figure A.
Okay. So, easy. Just see. Sin theta cos theta T1 sin theta is equal to 40
Do it. I am
T.
coming in a minute. Drinking some water.
Sure. T1 T2 cos theta. Sorry. T1 cos theta.
मैंने नहीं खाया, बच्चों ने खा लिया। क्लास है अभी मेरी, उसके बाद देखेंगे।
T1 tan 60. Done, sir.
Okay, what is your answer?
T2 is equal to 40 by root 3.
How?
You divide them.
How it is 42 by root 3?
40 by root 3. 40 divided by root 3.
40 divided by root 3. How much it will be?
I don't know.
I don't know. Just use the calculator, yaar.
Not allowed to use calculator.
40 divided by root 3, 1.732.
What? 1 second. Yeah, this will be 23.5. 23.
Okay, very good. And what about?
And T1 should be 80 divided by root 3.
Okay, so that
So double
means
that.
double that. Okay, yeah, right answer. Very nice. Very good. So that means you understood that concept. Just try this one. Today we'll do another topic also.
Okay.
Okay. So some questions will, that is the last question for practice. After that I'll give you as a homework. Okay.
Okay.
And then we'll have,
So, in the diagram, why have they taken the vertical as cos?
see, don't be confused about it is vertical as cos. Along theta it is always cos.
Okay.
Okay. If it is a vector, let us say this is your vector and this angle is given as theta. This is your vector A. So that component will be A cos theta. Okay. So with theta it is taken as A cos theta, and without theta it is taken as sin theta. Got my point?
Okay.
So that's why it is taken as T cos 4, because it is along the vector. Along theta it is.
Okay. Sure.
Okay, done.
1 second, sir.
do it fast. After that, we'll have topic.
So can you explain this question?
It is very simple, yaar.
I have some idea like the T sign for is acting in the direction of the movement of the train, right? So
So T sine 4 will be MA
yeah, I know that, but like, okay, why would it be MA?
because it is in the direction of movement. So that will be resulting like,
Wouldn't it be equal to the velocity?
why it will be equal to the velocity, yaar? T is the
Because
tension,
it's
it is
in
a
the
force. It is a force. So force will be equal to the force.
so T sign 4 would be equal to MA.
Yeah. And
Okay,
T cos 4 will be equal to mg.
MG. But we
Go.
don't need that, right?
Yeah. So whatever we need it, we just apply it.
T sign 4 equal to the M. So
Oh,
T sign 4 upon M, is that the answer? Hello?
yeah. You need to find its acceleration.
Yeah, T sign 4 divided by M.
Uh, T cos 4 is mg. T sine 4 is
MA.
ma. So if you divide 2 by 1, 2 by 1, what will happen? T
T
sine
gets
4 by T cos 4 equal to ma by mg. Cancelled, T cancelled. So A will be G tan 4. A would be G tan 4. Okay, got my
Yeah.
point?
Okay.
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 So that A would be, if you calculate everything, that will be 0.7 meter per second square. 0.7 meter per second square. Got it?
Yeah.
Okay. Now we'll discuss about work done against friction. Okay. So after this, we'll do work done against friction. Okay. So acceleration of a body sliding down a rough inclined plane. So what will happen if the body is inclined and it is sliding down? Let us say this is your inclined plane, and on this inclined plane the body is sliding down. Let us say the mass of the body is m. So how many forces will be applied on this mass?
It's not smooth, right?
It it is smooth.
It is smooth.
Yeah.
Okay. Then there would be the normal
And
first.
some that may be smooth or not. Okay, some sort of friction may also be available.
Okay, so first shall be friction, opposite to the direction of.
Yeah, so
Yeah.
friction of force will be in this direction.
Yes. Then there would be the normal from the uh, ground or the wedge.
Normal will be this.
Yes.
That will be
Uh,
reaction force, we can say.
yes. And then there would be the mg.
Mg will be downward.
Yes.
Okay.
And then there would be
If
uh,
if the angle of inclination is theta, then what will
yeah.
happen?
So the acceleration would be mg sine theta.
So if you take the component of mg, so that component will be mg
Sine theta.
sine theta. Excellent. And what will be another component?
Mg cos theta, but we won't need that, right?
That would be mg cos theta,
Yeah.
isn't it?
Yeah.
Because this angle will also be theta, so that would be mg cos theta. First of all, you need to draw a free body diagram, then you will understand what is happening, how it is happening. Okay.
Yeah.
And we say, generally we say that normal force is a reaction force. Okay. So just make the equations. First one, mg cos theta will be balanced by r.
Yeah.
So the first equation would be r is equal to mg cos theta. What will be your second equation?
This is equal to mg cos theta. Uh, then f is equal to mg sine theta if it's not in motion.
Yeah, but it is in motion. It is sliding down.
It is sliding. Okay, then that is not there.
If it
Then
is sliding down, then it will also be having a acceleration.
yeah. Okay, so then that's not
So
possible.
that
Okay, that's
means
it.
in previous type of questions we already seen that if it is sliding down, that means mg sine theta will be more than the friction,
F.
and the difference between these two will create movement,
Yeah.
isn't it? So what is that movement? So mg sine theta minus force of friction will be equal to ma,
Yeah.
isn't it? So that will be your second equation. Okay, got my point?
Yes. Yeah.
And you already know that friction force is always equal to mu. Mu is the friction constant,
Yes.
mu and r. Got it?
Yeah.
So we can replace force of friction by mu r. Okay. So we can write mg sine theta minus mu r equal to ma. Got my point?
Yeah.
And you can put the value of r also from equation number 1. So mg sine theta minus mu mg cos theta equal to ma. M will be cancelled from both the ends. So you can make g as a common, mg as a common. So it will be sine theta minus mu cos theta equal to ma. M will be cancelled. So your acceleration will become g sine theta minus mu cos theta. So that will be your formula. Okay, either you can use it directly or you can do it by conceptually like we did here. Okay, is there any doubt?
No.
Okay, so are you ready to do questions?
One second, sir. Let me note it down. Some part of.
And if someone is asking you how much is the work done, okay, just note it down, this one only.
Done, sir.
Okay, now we'll do some exercise based upon these type of questions. Okay, this is a question, can you see it?
Yes. The coefficient of friction is mu, right?
Yes, you just make a free body diagram. Okay, first of all you
Okay.
need to make a FBD. there some work is going on in your house?
No, it's happening outside. Actually, the window's partly open, that's why.
Okay, okay. Please close the window if it is possible.
Okay, sir.
It is very noisy. I'm also sending these two exercise to you. Okay. I forwarded these two sheets.
Okay, sir.
And tomorrow we'll finish this chapter. But the condition is you need to finish the whole exercise, the homework I sent you.
Yes. Just be right.
My live viewers, you can drop answer in comment box.
Student cost adjacent and hypertension 1.5. So R is equal to mg cos theta, which is equal to 40 into root 2 by 1.5. So 40 divided by 1.5. Just 40 divided by 7. 40 upon 3 is equal to mu into 40 root 5. So 40 root 3 into 1.5 by 40 root 2. 40 gets cancelled. So the answer is 1 by 2 root 2.
Yeah, you are right. So after calculation, it becomes 0.35.
Okay.
Okay. So now you got the idea how to do these questions.
Yes.
Okay. Now this NLM is kicking into your mind.
Yeah.
Okay. As you go for more questions, then it will be more clear concept about NLM. Okay.
Okay.
So tomorrow we are going to take that circular motion as well as the remaining topics of this chapter. Okay.
Okay.
But
What all is remaining?
sorry,
What all is remaining?
remaining these are small topics. We'll finish it tomorrow. Okay. But you need to do this exercise completely.
Both of them, right?
Yeah, both of them. These two exercises I sent you. So these two exercises is to be completed. Okay.
Sir, are these questions for JEE or NEET?
They are for the level of JEE and NEET also.
Okay.
Okay. The levels are bit higher.
Okay.
Got it?
Yeah.
Then we'll solve your Allen PDF.
Yeah.
Okay. Send it to me today. Then we'll discuss it in the class. Make a PDF of questions and solutions. We'll
Yeah, okay,
discuss it.
no, Alan already sends us a PDF of it on the app.
Uh, okay, I'll see it. I'll see it.
I'll send it to you.
Okay, okay. Oh,
The questions, right?
yeah, questions and the solution also if it is there
Yeah,
with you.
solutions is also there.
Yeah, so send all these. Okay.
Okay. Yeah.
Okay then, Vihan. Bye bye. See you.
Thank you.
Bye bye.